Hello students, today our topic of discussion is drift velocity. So what is drift velocity? It is the average velocity with which free electrons gets drifted in a direction opposite to that of the applied electric field. So you know the electric field goes from positive charge to negative charge, and here the electrons that gets drifted in a direction opposite means from negative to positive. So in a conductor you can see these are the electrons, they gets drifted in a direction opposite to that of the applied electric field. So now in order to find the value of drift velocity in the conductor, you have seen these are the free electrons and this conductor is under the influence of electric field. So when a charged particle that move under the influence of electric field, then how much force is experienced by that charged particle, that is given by F is equal to minus E into E. And this relation come from a relation which you have studied in the unit number 1, that is electrostatics, that is the force on the charge when placed in a uniform electric field, that is F equal to Q into E. This is the logic behind this relation. So here the charge particle is electron, that's why here it is negative. So F is equal to minus E into E. So here negative sign indicates that E and F both are opposite to each other. Now as the electrons are drifted, so the acceleration produced in the electrons is A is equal to F over m, where F is the force on each electron, m is the mass of each electron, and this relation came from Newton's second law, that is F is equal to m into A. So A is equal to F over m. Now we will fill the value of F from above relation, that is F equal to minus E into E in this relation. So acceleration will become minus E over m. This is relation number 1. Now here is a point which you need to understand, that this acceleration is for very short time. अब बेटा ये जो acceleration है ये बड़े थोड़े टाइम के लिए है and gets interrupted, और ये interrupt हो जाती है and which is approximately equal to 0. So now why it is approximately equal to 0 and why it gets interrupted? So actually it gets interrupted due to the collision between the electrons and the ions of that conductor, and also the collision between the electrons and electrons. So when the electrons and ions they get collide with itself, then what happen? They will lose their energy, and if they lost their energy, then they relax for some time, means their velocity gets decreased, and then they relax, and for how much time they gets relaxed, that time is known as relaxation time. And this is also the basic cause of resistance. बेटा रेजिस्टेंस का कॉज भी यही है कि जब भी किसी कंडक्टर में से हम करंट पास करते हैं, सो उस कंडक्टर में जो रेजिस्टेंस बनती है वो भी इसी वजह से बनती है कि जो इलेक्ट्रॉन्स हैं और जो आइंस हैं कंडक्टर के, जब वो एक एंड से दूसरे एंड पे चलते हैं तो उनका आपस में कोलिजन होता है, जिसकी वजह से एनर्जी लॉस होती है. वो थोड़ी देर के लिए रिलैक्स करते हैं, और जितनी देर के लिए रिलैक्स करते हैं तो इट मीन्स दे गेट सम एक्स्ट्रा टाइम टू गो फ्रॉम वन एंड टू द अनदर एंड. तो यहाँ भी कुछ बेटा ऐसा ही होने वाला है. तो यहाँ मैंने लिखा है दिस एक्सेलरेशन इज फॉर शॉर्ट टाइम, एंड रीजन आई हैव टोल्ड यू दैट व्हाई दिस इज फॉर अ शॉर्ट टाइम. So due to collision they lost their energy and relaxed for some time, which is known as a relaxation time or mean free time. बेटा मीन फ्री टाइम का जो सिंबल है दैट इज टॉ, जिसको हम टॉर्क भी पढ़ते हैं. सो द ड्रिफ्ट वेलोसिटी विल बिकम वी डी. वी के मैंने एक बेटा सबस्क्रिप्ट लगाया डी, सो वी डी स्टैंड फॉर drift velocity. So Vd is equal to u plus a tau, where u is the initial velocity, a is the acceleration, and tau is the mean free time. And this relation came from the kinematic relation, that is v equal to u plus at. Now since as usual u equal to 0 means initial velocity, that is equal to 0, so Vd, that is drift velocity, will become 0 plus a into tau, and we will use the value of a, that is a equal to minus e over m. E is the charge on electron, capital E is the electric field, and m is the mass of electron. So when we fill this value here, we have Vd, that is drift velocity, equal to minus E m into tau. So if we take the mode of this relation, then Vd will become E tau over m. So from this relation, we have concluded that drift velocity is inversely proportional to the m and directly proportional to the E and tau, that is the relaxation time. So one thing is important in this relation, that why the electrons gets relaxed during their journey, and that is also the main cause for the resistance. Thank you, beta.